I'll tell you now. The Hooke's law is nothing but the spring force. Huh? The force is directly proportional to displacement. Stress is directly proportional to displacement. So what is Hooke's law? I tell you, Hooke's law, what it says. Stress is directly proportional to strain. What do you mean by stress? Stress means force by area. What do you mean by strain? Change in length by original length. Like this for, if you look at the spring, so that the Hooke's law is what this particular says. So he's telling some information, you see, very good information he has put it really. A spring obeying this property and Hooke's law is called as a linear spring. A uniform massless spring, if extended component, the distance between every two consecutive turns changes by the same amount. Something telling. So if you look at the spring, no, it will have turns, no, that each turn is also called as the distance between two consecutive turns. The distance between turns is called like a pitch. So if you take a spring, I'll draw the diagram. Huh? So what is the basic, the diagram? You read the question. Meanwhile, I'll end up with a diagram. Okay, what is a turn? So this is the 1, second turn, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12, 13, 14. Like this, we can assume the number of turns. Wait. Let me, I want answers. No? Find the force constant of the spring. Okay, 1, 2, 3, 4 like this. Okay, this about the spring here, 15, 16. Okay, let it be that one. So now what is the question? A linear spring of relaxed length L naught. So what is the length of the spring? Let it be L naught. So let's assume that some 16 turns are there. Okay, now what I do is I'm going to this will be position. The sixth turn. I'm taking some account to the question. The sixth turn will come to the position of the eighth turn. Three, 4, 5, yeah, 6. So what is the state of spring? It got elongated, no? So just show it more length, that's all. So this was the 1, 2, 3, 4, 5, 6. Okay, look at the sixth turn. The sixth turn came to the position of the eighth turn, no?
1600 Newton per meter.
Wait. And I'll check. I'm discussing concept, no? Please let me finish off. In the end, you can answers. You please wait, because I'm explaining concept, no? So this will be 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So therefore, so now this is the distance L6, no? So it got displaced. So now this should be the, so how much of spring force. So now for that I'll apply a force. So here what happened, I'm going to apply a force. Find the force constant of the spring, a force of 60 Newton, as he has given that also. I applied a 60 Newton. Now this about overall the thing, that one force applied, length of the spring given 30 centimeter. The sixth turn will be at the position of the eighth turn. With this information, we have to calculate now what is the spring constant of the spring. Okay, got the idea now. So now what is the number of turns per unit length? So we'll assume that one. So how many others? N turns. Here I shown n 16 turns. Let there be n turns. So let n be the number of turns. Let n be the, in the question I shown 16, it can be anything. Let n be the number of turns of spring. Okay, now what is the length of L6? Here the distance I shown you some gap, but practically I think if you just open some spring in your pen, no, that one. So what is the gap between individual turn will be almost negligible. Distance between consecutive pitch changes by same amount. Here to make you understand, I brought a gap, but practically what will be this gap? This gap will be almost negligible. Will I agree, all of you? So therefore, with that information, what I can write now? To make you understand, I do diagram like this. Otherwise, what happened? The gap should not be there between the turns. The turns what happen will almost come in contact. So what is the for 6 coils? So length, I'll define quantity called as lambda. So what is the lambda? Length per number of coil. Length per number of turns or coils. Anything. Since we used word, okay, turns are right. Turns or coil. So shall we go for n by L naught? Oh, sorry, L naught by n. There's a one assumption I'm making it. Now, what is L6? Anybody? What is L6? You should write. What is L6? You should write.
6.
L6. I'm going to write it as 6 turns into lambda, or 6 L naught by n. What about L8? 8 lambda, 8 L naught by n. So displacement of the coil. So what is the displacement of the coil now? So it should be L6, L8 minus L6 is what X, no? So from the diagram, what is X I should write now? So this X should be called displacement of sixth turn. Should be equal to, X should be equal to L8 minus L6. So this should be equal to how much? 8 lambda minus 6 lambda. I'm just, you can solve by any method. Just I'm using the procedure. This will be. So 2 L naught by n. Now come for this. He has put one condition. The distance between every 2 consecutive turns changes by same amount. So what do you mean by that one? The strain of any part of string should be equal to the total strain of the spring. That is what this sentence I'm going to convert it. I am writing that one. So what is the meaning of this sentence? See, most of you might have studied in school the springs, but this particular idea is what is not being put, not being expressed even in book. But this is something very basics of the spring. I don't know why books and teachers have missed it. So what do you mean by this? The distance between every 2 consecutive turns changes by same amount. Means the strain in any part should be equal to the total strain of the spring, or the strain in one part should be equal to strain in the other part of the string, or the strain in one part of the string should be equal to strain in total string, that one. So here the strain in one turn, this is the question itself he has explained, that I'm going to interpret here now. Strain in one turn. There's a property of spring, sir. Why you are writing this equation? The question itself is that, what do you mean by spring? The spring which we are discussing is having this particular property. Strain in total So from where this you brought it? This is the property of a spring itself. I am writing it this one. Don't question this, sir. Practically, if you take spring and do measurement, no, it will do obey this particular thing. So what is the strain in the particular thing, that one? How to get this particular thing? So x by L6 shall I write? Strain in one turn, strain in the sixth turn, x by L6 should be equal to strain in total string, total elongation, let it be xt. I didn't write total elongation, you see. There should be xt and length is L naught. Okay, let's substitute all the things now. So we know what is the, I'll proceed down. Anybody, what is x? X we know, 2 L naught by, I think I can write it here only. 2 L naught by n. What is L6? 6 L naught by n. Equal to, so this should be xt. What is xt? In place of xt, what you can write? The f should be equal to k xt, no? Can you remember this? So what is the total elongation of spring is xt. Then how much of force we applied? We applied a force F equals 60 Newton. What this should be equal to? This will produce elongation of xt, that one. So what is the applied force? It is given 60 Newton. So what is the spring force? Will be xt. This is what applied force. This is what spring force. So therefore, in place of xt, what I can write? F by k, and this is L naught. So we wanted expression for k, no? So anybody value k will be?
3, sir.
3, sir.
K equal to how much?
3, sir.
3, what is 3?
4, sir.
No, 60 Newton, you know, L naught get cancels, L naught get cancels. L naught get cancelled, so n get cancelled, so 3, so this k should be equal to
6, sir.
6, sir.
no,
6.
no expression for in terms of f L naught you give it. 3 f L by I'll write it. 3 f by L naught. Okay, fine. Substitute value of f, and L naught is how much given?
30.
Okay, 30. Convert that into meter and check it. How much you'll get value of k? 3 into 60 by L naught is 30 centimeters, so 0.3 meter, no? So how much value of k will be? I'll proceed to the next. So k should be equal to 3f by L naught. So 3 into, what is the value of f? 60. What is L naught? L naught is 30 centimeter. 30 centimeter, or 3 into 60 by 0.3 meter. So this should be 600 Newton per meter. Okay, fine. This should be our answer. Of all this, this is the property of spring, which you remember, really going to help you a lot. The strain in one turn is equal to strain in total string, or strain in one part of the string is equal to strain in other part of the string. This is one basic property of the spring itself. So he has put this information in the question. I don't know, it is very badly missing in our books, and the teacher also never bothered to stress anything. No, meter, no. This is spring constant. What is the unit for spring constant? Force by displacement. Okay, after this is asking now the second part of the problem. Come for second part. The ends A and B of linear spring of relaxed length L naught are so pulled that the end shift by distance delta LA and delta LB as shown in figure. Find the shift of a point of spring that was at a distance L naught by 3 from the end A in the relaxed spring, that one. Okay, now look at this. So what is asking? There are two ends are there. There's a spring. So there's a point P is there. At what distance it is? At a distance of L by 3. At a distance of L by 3 from the end A. So what is the displacement of that point is asking? How to bring that? All of you, if you read question, I think I can explain you on the top itself. No? We have a space here, no? And I'll bring it here. And this is again one more very important information which a student must have that one. See, before entering any numericals, no, you must have this one basic property. There's a end A and end B, and there's a point P. So where is the point P? Is telling like it is at a distance L naught by 3. Total length of the spring is how much? 2 L naught by 3. So how much the end A and end B, they are displaced by some distance. Both are having same displacement? No. The end A is displaced by, I'll just call XA rather than delta XA. No, let me call only XA. No problem, that is. The displacement of this. The displacement of this end is asking what be the displacement of this point. I don't know this point where it will be for our understanding purpose. Somewhere I put it. I don't know displacement right or left. That should be brought from the answer. You try to. I'm giving some reference diagram. This is what is happening. Yellow color lines are you seeing? So is it a displacement of point P towards right, towards left? We don't know. Yeah, any other information given? Nothing. Only this much, sir. How do we can tell displacement of point P? Shall we say displacement of point P is 0? So again, I'm asking you to go back to distance between every two consecutive turns changes by the same amount. Or nothing but I wrote one formula. What is that? Strain in one part of spring should be equal to strain in other part of the string, other part of the spring. So we'll do one thing. Like here the displacement B is towards right, no? Anything directed towards right, I'll take it positive. Anything directed towards right, I'll take it positive. Okay, now let's analyze. I'm not sure about the displacement of the one which you don't know what pen, we don't put sign. So change in length of like a AP by original length should be equal to change in length of BP by original length. So nothing but the strain in one part of the string should be equal to strain in other part. The core idea, property of spring. Don't forget here. See, like I know many of you have learned just some teachers shown some method. Okay, how to find out spring constant, string speed is parallel, that one. But in advance, when you go for Olympiad, no, definitely they will stress you how far you are very good in the basics, how far you know basics and how you can apply. Just like if you gather information, go to the Olympiad, no, definitely in a big trouble. Now, strain in shall I put like this? Strain in part PA should be equal to strain in part PB. Again, the same property of spring. So I'll write it here. Strain in part PB is equal to why you find this pathfinder very difficult means some hidden concepts are there which are not reflected in book. That's why though you know all the ideas, everything, no, still when you go there, no, the core idea is what happened. That itself, what happened, clarity will not be there. That's why what happened, the pathfinder will take more time for you to solve problem. Yes, there's a way of that book itself because the book is meant purely for what like the out of 22 problems in advance may come of pathfinder or you can put out of 20 around 5% of numericals will be of the pathfinder type. The remaining 15 as usual, typical normal book, what we have Engage other thing. But if you go for Olympiad, no, this book is what the best thing. Almost every numerical will be the numericals of this kind in this book. So those who are targeting for Olympiad, it's a compulsory. Those who are targeting for advanced, better rank, you must put effort. At least need not to solve 100%. Even if you solve 40% or even you solve 30% also enough. But daily make a practice of solving at least two numericals. Just take two numericals and try to work out. Just try to think on them. Okay, what is the strain in part A, that one? So here minus XA. Why negative sign? The displacement of end A is towards left, no? Minus of XP. I don't know this. I'll not put sign. Divided by, what is the length of this? L0 by 3. What do you mean by strain? Change in length by original length, no? Should be equal to XB. What is XB, no? XB equal to how much I should write? Plus XB minus XP. So I'm not sure about XP direction, so I'm leaving it by 2 L0 by 3. Okay, solve this, you'll get the displacement of point P. Anybody value? L0 by 3 get cancelled, so this will be minus 2XA, minus 2XA, minus 2XB, 2 by 3, no? So 2 by 3 equal to XB minus XP. So this will become XB plus 2XA by 3 should be equal to 2 by 3 1 plus 1 minus 2 by 3. So XP by 3 will come. Just substitute this value. So therefore, what is XP is equal to? XP should be equal to 3XB plus 2XA. Uh, 2 by 3 minus 1. No?
Sir, L0 by 3 will be cancelled, sir.
Yes, sir. L0 by
Yes,
3
sir.
will be cancelled.
L0 by 3 will get cancelled. Huh? So I think that, okay, this 2 will not be there.
3 will not be there in the denominator.
3 will not be there. Okay, fine. I'll make correction. This will become 2XB plus XA, 2XA. Then this should be only XP. Yeah. Anybody value? XB, XA, how much given? The displacement. Already I substituted sign. Huh? You need not to bother. Already I substituted sign. So what is XB equal to? 25.
35 centimeters.
35, sir.
35 centimeter. check once. Is this anything went? Everything is in order. I want you to analyze the problem.
Sir. Sir will get minus 35.
No. So something still most of you are not observing the condition.
It will go to the left side.
Yes, it will go to the left side.
No. I'm not bothered answer. Left or right, leave it. I want you to really think once here. Really, everything is fine because still most of you are not.
Sir,
I
have a doubt, sir.
Yeah. I just yes. Yeah.
In the question, he gave distance between every two consecutive turns changes by the same amount. So it means displacement of one turn will be equals to displacement of each and every turn in the spring rates.
No, the distance between every two consecutive turns changes by the same amount. Okay, that one. There's the one thing. Okay, now come for this. I'll explain you that one. Okay, come for this. Any problem arised here? I'll come back to your application. So anybody, can you say anything happened here in the formula? Did we apply it properly? Because this is something very important. How to use this formula is what we have to learn.
Sir, we'll get XP negative, sir.
Okay, no, I don't bother answer. I'm asking you to look at this equation. Look at this equation. Don't bother answer, whatever the answer. Let's come for this. Is this properly we applied? See, altogether, what will happen? The spring what happened? The displacement of NB is how much? 25 centimeter. This is 5 centimeter, no? That will be. So what will happen to all parts of this spring will have same displacement in all direction. There can be some point which will be at rest, no? I think nobody made observation. There'll be some point on a spring which will be at rest. So therefore, this particular formula is what will happen. It should be like this. XP minus of, this will be XA. What is XA? XA is towards left, no? So I'll put it. So we are not sure. We're just assuming that the NB is having more displacement. So I'll just assume that one. So I'll do like this. XB minus XP by 2L0 by 3. 2L0 by 3. Then XP minus of minus XA. So since XA was displacement towards left, no, I'm writing this. Got the idea, no? This one. Now you substitute and solve it. If you get XP negative, that particular point P is having displacement towards left. If you get XP positive, that particular point is having displacement towards right. Got the idea? So,
I didn't get it, sir.
I'll finish. I'll just let me work out the calculation part. I'll come to the explanation, that one. So here this should be, I'll erase all this. Okay, that particular formula again, the question, the formula given, no, that is something very, very important, that one. All our ideas revolve around that particular formula. Okay, now come for this. This should be 2xp plus 2xa is equal to xb minus xp. Okay, so solve this now. XP will be 5 centimeter. Yeah.
Yes, sir. 5.
Check the answer given in the book will be 5 centimeter. Means what happened here? So we have to be very careful about the strain. How you define strain? So don't measure strain, because the strain should be positive. What all you calculate strain, no, is telling like the strain will be equal at all points. The change in length by the distance of the change in one part, the change in length of one part by length of the part, that should be constant throughout the spring. So therefore, xb minus xp should be equal to xb minus xp by bp should be equal to what? Xp minus of XA by PA. So what you have to take care is, you have to take care in such a way that the strain is equal. No? So if I write previous one, what I did there what when you are telling that strain positive, here strain negative. No, the strain is same everywhere. The strain in one part of the string should be equal to strain in other part of the string. So therefore, what do you mean by strain? Change in length. So XB minus XP by 2L0 by 3 should be equal to XP minus XA by L0 by 3. I think the basic formula, we should apply it properly. So here I'll change it. So this is what some books they have given wrong like this also, but this should be the correct. Strain in one part of the spring should be equal to strain in other part of the string. That's what the meaning of this particular sentence. Don't assume in other way. The meaning of this sentence is the strain in one part of the string should be equal to strain in other part, or strain in one part of the string should be equal to strain in total part of the string. Getting the idea now? Sir, can you locate a point where the displacement will be 0? Can we locate a point on a spring where the displacement will be 0? I'm giving it as a question. Can we find out? So you have to put XP, no? So I'll come to the question.